So, in an arithmetic sequence, the difference between each pair of consecutive terms is the same. That's called your common difference. So how much you're adding or subtracting each time is called your common difference. If I look at 5, 10, 15, 20, I'm adding 5 each time, so my common difference is 5. So if your common difference is positive, you're adding. If it's negative, you're subtracting. Okay? How do you find it out if you can't just look at your numbers? You take your second term minus your first term. Okay, so A2 minus A1, your A is like the term, the subscript is the position of the term, I guess you could say. So second term minus first. Alright, so there's going to be a section on your worksheet where it asks to determine if it's arithmetic or not. So it has to be adding or subtracting the same amount each time. So from -4 to 1, what am I doing? I'm adding 5. From 1 to 6. From 6 to 11. 11 to 16. Plus 5. Okay, yesterday I wrote out the formula 1 minus -4. 6 minus 1. 11 minus 6. You would do that if you couldn't easily tell what was going on. But if you can easily tell, you can show me this. Okay? So then my answer, since they're all the same, my answer is arithmetic. And my common difference is 5. Now, if it wasn't arithmetic, then there's no common difference. You would tell me there is no common difference. Okay? But that's as simple as that gets. Your rule for an arithmetic sequence, so A sub n is your nth term, so that's pretty much like a y. Your A1 is your first term, your D is your difference, your n is like your x, so that n is like the position of that term in the sequence. Now, this is pretty much a linear function, okay? We don't say that necessarily because it's a sequence, not a continuous function. So a sequence is a discrete function, meaning it could only be specific values. It's not continuous, okay? So we're going to relate it back to a linear equation, though, okay? So in any textbook that you might ever see, this is the formula for arithmetic sequences, okay? A sub n is equal to A1 plus n minus 1 times D. We're gonna, if you were working this out, we would distribute that common difference, okay? So you would get A sub n is equal to A1 plus dn minus D. Well then, if you were working with numbers, these two would be constants. You would combine them and basically get A sub n is equal to dn plus a number. Okay? Well, that's how we do it in Algebra 1. Next year, when you do sequences, Miss Baker teaches it A sub n is equal to dn plus a naught. Okay? So, because this is really linear, you are used to seeing y equals mx plus b. It makes more sense to relate this back to y equals mx plus b. Your d is your common difference. That's pretty much your slope. Your a naught is pretty much your y-intercept. So what is a naught? Well, a naught is the term that comes before a1. So you will have to calculate that. It's not hard. You take A1, subtract your D, and there's your A naught. Okay? I told my kids yesterday that it didn't matter which way you did it, as long as enough work was there for me to understand what you were doing. Okay? So, I'm going to show you both ways for this first example, and then the rest of the time I typically go with this. Okay? Now, there are going to be times where there's no other option. We have to use this formula, so be familiar with it. But as far as getting your equations, it's up to you with what you want to do. All right. So this first example says, write the rule for the nth term of an arithmetic sequence with the first term of 2 and a common difference of 3. So my first term, A1, is 2, and my common difference is 3. If I was using this formula that is from a textbook, I would have A sub n is equal to 2 plus n minus 1 times 3. I would take that 3 and distribute. So A sub n is equal to 2 plus 3n minus 3. Take my 2 and my negative 3 and combine them. An is equal to 3n minus 1. Okay? That's the work with the formula. Now this one, I will need to solve for my A naught. Well, A naught is just A1 minus D. So I've got 2 minus 3, which is negative 1. So my equation, An is equal to Dn, so my D is 3n minus 1. Okay? You get the same answer either way. You decide which way you want to stick with it. Okay? Now it says, then write the next 4 terms of the sequence. Well, you've got to continue it. So if my first term is 2 and my common difference is 3, what are my next 4 terms? 2 plus 3 would give me 5, plus 3 would give me plus 3, plus 3. So continuing the sequence. Can I go with that? Okay. Now, I gave you the sequence 4, 9, 14, 19, and you write a rule for that, and then you're going to find A15. Okay, so here, my first term, A1, is equal to 4. If I'm going from 4 to 9, 9 to 14, 14 to 19, what am I doing? I'm adding 5, so my common difference is 5. Okay? I'm going to choose to find my A naught. So, my A naught, I take 4 and subtract 5, and that is negative 1. So if you're choosing to do this way instead of using the formula, that's fine. Make sure you show me how you got this value. Okay? So then my equation, An is equal to Dn, so 5n minus 1. Okay, then I need to find A15. Well, what does that 15 tell me? That's my n. That subscript tells you what your n is, so n is equal to 15. We're going to plug 15 in. So A15 is equal to 5 times 15 minus 1. So A15 is equal to You're good with that? Okay. Any questions? Alright, now, what if I give you a specific term that's not A1? Alright, I'm telling you that A19 is 48, and I'm telling you the common difference is 3. What am I missing? A1. So what I'm going to do is this is the time where I need to actually use my formula to find my A1. So AN is my A19, which is equal to 48, equal to A1, plus, what's my N value? 19 minus 1, my D is 3. So I've got 48 is equal to A1 plus 19 minus 1 is 18. 18 times 3 is... Alright, how am I going to solve for A1? Subtract your 54. A1 is equal to -6. Alright, so I know what my A1 is. What do I need to find now? If I need to write an equation, I could take my A1 and I could take my D and go through the formula, or find A0. -6 minus 3 is -9. So A sub n is equal to 3n minus 9. Y'all good with that? Alright, now what if I give you two terms in the sequence, but I never give you A1? And I never give you the common difference. So what we're going to have to do is we're going to have to write a system and solve a system. We don't know our A1, we don't know our D, so we've got two unknowns. We're going to have to do two equations for two unknowns. Okay? So A8 is equal to 21, A27 is equal to 97. So how we started this one is similar to how we're going to start this one, except we don't know our D. Okay? So A8 is equal to 21. So I've got 21 is equal to A1 plus, I do know my N. My N is 8 minus 1 times D. And then I'm going to clear that up a little bit. Okay? 8 minus 1 is 7. So I can have 21 is equal to A1 plus 7D. I'm going to do the same thing for A27. So I've got 97 is equal to A1 plus 27 minus 1 times D. So 27 minus 1 is 26D. Alright, when I build my system, you can leave it like that if you want to. I'm not going to. I'm going to have it in my MX plus B form. Okay, so I'm going to have 7D plus A1 equals 21. And then I'm going to have 26D plus A1 equals 97. Again, it doesn't matter if you keep it in the same order, as long as you're not changing signs and you're not changing values. That's how I'm going to set it up. Okay? You could have kept A1 first and set the equal 21 equal 97. Up to you. Now, if I'm looking at this, every time I'm given this, my A1 should not have a coefficient. So that's what I'm going to get rid of. I can easily manipulate one of these equations and make it a negative A1 by multiplying by what? -1. So I'm just going to say let's multiply the first one and we can write it out underneath the system. So that gives me a -7D minus A1 equals -21. Writing it out underneath is just so I don't have to write the second equation twice. Up to you if you want to do that. Okay, so then 26D minus 7D is going to give me 19D. A1's cancel. 97 minus 21. Okay. Divide by 19. And D is equal to 4. Okay, so I know one of my variables. I'm still missing my A1. How am I going to find my A1? Plug it back in. Just like when you solved a system and you were solving for X and Y, you would take your X and plug it back in. So I'm going to take this D and plug it back into one of the originals. So I'm going to have 21 is equal to A1 plus 7 times 4. 21 is equal to A1 plus 28. Subtract your 28. A1 is equal to -7. Alright, so I got my A1, I got my D. Now I need to write the equation. Well, with those two, I can, again, plug them into the formula, distribute, combine like terms, or find your A naught. A naught is negative 7 minus 4, which is negative 11. So my equation, AN is equal to 4N minus 11. I'm good with that? Okay. Now that brings us to arithmetic means. All that is just referring to the missing terms between two non-consecutive parts in a sequence. Okay? So if I have 18 and I have 78, I want to know the four arithmetic means between 18 and 78. So what I'm going to do is I'm going to label this is my first term, second, third, fourth, fifth, sixth. So A1 is 18, A6 is 78. But I don't know my common difference. I have to figure out what I'm missing to know where I need to start calculating, okay? So I'm not going to find the common difference here, so what I'm going to do is use A6 equals 78. Know that that is my sixth term. Use my A1 and solve for my D, okay? So I'm going to have 78 is equal to my A1, which is 18, plus, parentheses, my N is 6 minus 1 times D. Okay, so I've got 78 is equal to 18 plus 5D. I need to solve for 5D, so I'm going to subtract my 18, and that leaves me with 60 equals 5D. Divide by 5, and D is equal to 12. Okay? I'm not writing an equation, so I don't need to solve for my A naught. All I need to do is use this common difference and continue and find out what these arithmetic means are. So if I go from 18 and add 12, what does that give me?
30.
Okay, 30 plus 12, plus 12, plus 12, and then plus 12 would give me the 78. Okay? Now, if I give you a sequence and I give you a term and I ask you which term is that in the sequence, which term is 89 in the sequence, I need to solve for my D, and then I need to get the equation. That's going to be the easiest thing to do. I would not take 41 and keep going on with that difference, because it could be, you could luck out and it could be a very quick adding to get to your term, or it could take a long time. So I'm not going to recommend just doing it in your calculator, okay? We're going to do the formula and do it algebraically, all right? So if I'm going from 23 to 29 to 35 to 41, what am I doing each time? Adding 6. So my common difference is 6. My A1 is 23. So what I need to figure out, I have my A1, I have my D, I know what that is, I just don't know my N. Okay, so that's what we're going to solve for. So I'm going to take this equation, not this equation, these two characteristics, and I'm going to form my equation. Okay, well, forming my equation, if I know my A1, what's my A naught? 23 minus 6 is going to give me 17. So my equation is AN equals 6N plus 17. I know my AN is 89. So in order to solve for N, I need to subtract 17. 89 minus 17. Divide by 6, and N is equal to 12. So 89 is the 12th term. Y'all good with that? Okay. All right, now I give you a sequence and I tell you find A12. We're doing pretty much the same stuff, okay? You need to find your role for this sequence. So negative 16, negative 13, negative 10, negative 7. What's my common difference? 3. And my A1 is negative 16. So my A naught is negative 16 minus 3, which is negative 19. So my equation is AN equals 3n minus 19. If I'm solving for A12, I'm going to plug in 12 for my n. Three times 12 is 36. 36 minus 19, 17. So I understand you could add 3 a million times in your calculator, but I don't want to see that. I want to see your algebra. Okay? Y'all have any questions over this? Alright, so you've got your worksheet to do. There's 20 questions. We are not going to have a quiz over this. I'm going to teach you geometric next class, and then we'll have a quiz over arithmetic and geometric together. Okay? Here's your answer key. It's also on the Google Slides. Y'all got the rest of the period to work.